Okay, today we're going to graph quadratic equations. My equation is y equals x squared minus 6x plus 11. What I'm going to do is I'm going to start by finding the vertex of my graph, and then I'm going to use my axis of symmetry to help me plot some points. So let's start by labeling our a, b, and c value from our equation here. So our a is what's in front of our x squared, that's 1. Our b, which is in front of our x, is negative 6, and then our c, which is our constant, is 11. So to find the vertex, I have to start with the x value, which is going to be negative b divided by 2a. So that would be negative 6 divided by 2 times 1, which is going to be 6 divided by 2, which is 3. So the x value of my vertex is going to be 3. So it's going to be 3 something. I know that my axis of symmetry is going to be x equals 3. So I can go over here to my graph and I can draw a dashed line at x equals 3, because that is going to be the axis of symmetry in my graph. So if I go back here, I'm going to take this 3 and I'm going to plug it into the equation in order to find the y value. So I'm going to say y equals 3 squared, instead of x squared it's 3 squared, minus 6 times 3 plus 11. Okay, so 3 squared is 9 minus 18 plus 11. So that means my y value is going to be 2. So that means my vertex is going to be 3, 2. So I'm going to go over here to my graph, and I'm going to go to the point 3, 2. And that is going to be the vertex of my graph, 3, 2. Okay, so now I have to find some other points, and I can see where I have my axis of symmetry. So if I find a point that's on the left side, then I can plot a mirror point on the right side. So since my vertex is 3, 2, I'm going to try one x value to the left. So I'm going to try to figure out when x equals 2, what's my y value going to be? So I'm going to go back here to my equation, and I'm going to say y equals, and now I'm going to say 2 squared minus 6 times 2. So I'm just plugging in a 2 in the equation, and then I'm going to solve for it. So y equals 4 minus 12 plus 11, which means my y value is going to be 3. So that means that my ordered pair for my next point is going to be 2, 3. So I'm going to go over here to my graph, and I'm going to plot the point 2, 3. Now, on the other side of my axis of symmetry, I can put a mirror point. So I'm going to go over here, and there's going to be 4, 3. So I have an additional point here that I can plot, and that's going to be my constant, my y-intercept. So if I look back up here in my equation, I've highlighted it in red there. You can see that means that my graph is going to cross the y-axis at 11. So I'm going to put a point up here on the y-axis at 11. Now again, this dashed line down the middle is my axis of symmetry. So if this is on the left side, then there's going to be a mirror point on the right side. Now this is 1, 2, 3 away from the axis. So I'm going to go 1, 2, 3 on the other side and put my other point. Now I can draw a graph connecting these points, and there is the graph of my quadratic equation. So it's a lot of steps, a lot of different ways to get those points. So let's practice that again. All right, again, the first thing that we're going to do is we're going to label our a, b, and c values. So a is 1, b is 4, and c is 1. So I have to find the x value of my vertex. So I'm going to use negative b divided by 2a for my formula. So that's going to be negative 4 divided by 2 times 1, which negative 4 divided by 2 is going to be negative 2. So I know my axis of symmetry is going to be where x equals negative 2. So I'm going to go ahead and draw my dashed line here. Okay, then I'm going to go back here and I'm going to say, all right, I'm going to take that negative 2 and I'm going to substitute that in to x in my equation. So I have y equals negative 2 squared plus 4 times negative 2 plus 1. So y equals negative 2 squared is 4. Then I have 4 times negative 2, which is negative 8, so minus 8 plus 1, which means y is going to equal negative 3. So my vertex, my ordered pair for my vertex is going to be negative 2, negative 3. So I'm going to go over here and I'm going to plot that point. Negative 2, negative 3 is right here. All right, so I'm going to try to see if I can find some points that I can use my axis of symmetry to make mirror points. So I'm going to move one spot to the right. I'm going to choose negative 1. So I'm going to figure out what does my y value equal if my x equals negative 1. It's going to be negative 1 something. So let's figure that out. So I'm going to take y equals negative 1 squared plus 4 times negative 1 plus 1. So let's see, y equals negative 1 squared is positive 1. 4 times negative 1 is going to be negative 4, so minus 4 plus 1, and that means that y is going to equal negative 2. All right, so our next point that we're going to plot is negative 1. That was the x value, and negative 2, that was our y value. So negative 1, negative 2 is going to go here. And then I can go to the other side of my axis of symmetry and I can plot a mirror point. All right. So the next thing I'm going to look at is this y-intercept. We talked about this in the last problem also. If I go back up here, I will see that my c value, or my constant, is positive 1. That means I am crossing the y-axis at positive 1. So I'm going to plot that point. And then I'm going to do the same thing. I'm going to go over here and do a mirror point. So now I can connect these dots and make my graph of my quadratic equation. Awesome. Let's take a look at one more example. Okay, again, I'm going to start by labeling my A, B, and C. So my A is negative 1. My B is going to be negative 4. And my c is going to be negative 2. All right, so let's do this negative b divided by 2a to figure out the x value for my vertex. So negative b would be negative 4 divided by 2 times negative 1. So that's going to be 4 divided by negative 2, which is negative 2. So I'm going to go back over here. And I'm going to mark my axis of symmetry at x equals negative 2. That's going to be the line that cuts down the middle of my graph. All right, so I go back over here, and I say, well, let's figure out what that y value is. So I'm going to take that x, and I'm going to substitute it into my equation. So instead of negative x squared, we're going to have negative 2 squared minus 4 times, substitute that negative 2 in there, and then minus 2. So we got to be very careful with our positives and negatives here. So order of operation says I have to square this number first. So negative 2 squared is positive 4, but then I have to bring the negative in front of it down too. So I've got negative 4. Negative 4 times negative 2 is going to give me a positive 8, so plus 8 and then minus 2. So if I simplify that, I'm going to end up with positive 2. So that means that my vertex is going to be negative 2, positive 2. So I'm going to plot that point, negative 2, positive 2. There's my point. So again, as we talked before, I'm going to go one spot to the right or to the left of this axis of symmetry to find my next point. So I'm going to go to x equals -1. So if x equals -1, we have to figure out what the y value would be. So y equals -1 squared. All I'm doing is substituting this in the equation. And then I'm going to simplify. All right, so -1 squared is 1, and then I have to bring the negative down that's in front of it. -4 times -1 is going to be a +4, and then -2. So y equals 1. So that means my new point that I'm going to plot is going to be -1, 1. So I'm going to go -1, 1. And again, I can always have a mirror point. So there's my mirror point on the other side of my axis of symmetry. So if I look here, I also have, again, my y-intercept that I can use up here from my original equation. My constant is my y-intercept. So I'm going to go over here. My y-intercept is -2. So I'm going to put that point on my y-axis. And then I'm going to go over and I'm going to plot that mirror point. And again, I can see this graph is actually going to open downward, which that negative in front of the x squared is what's causing that to open downward. So I hope this information has been helpful as you're learning to graph quadratic equations.